that's written above is that it's perpendicular to the major axis. So if this is the major axis, it is perpendicular to it, but it doesn't go through the center. It actually goes through the focus. One or the other, same thing. I think these would both be considered, this segment here, if I were to draw it in, that's latus rectum. So it's definitely going to be shorter than the minor axis. The minor axis is definitely 2. The length of the latus rectum, though, has a formula that you need to know. So length of latus rectum right here. LR equals 2b squared over a. So I wrote that down here. You should write that too. 2b squared over a. And then if you go back and you look, b squared was 1, right? So 2 times 1 over a was just 2. So the length of that latus rectum was 1. I also fixed, just to get it perfect so I could wrap my head around what's going on and to see if that number made sense, I also fixed where my foci were. So remember, I knew it was like root 3 units above 3 and root 3 units below, but we don't really know how much root 3 is. Root 3 is like 1.5, 1.7-ish. So I went like 1.7-ish units to the left when I do the center minus that focal distance, and when I do the center plus that focal distance, I went like the actual 1.7-ish. So this should look better. So the length of the minor axis is 2 units. I mean, we could count that out, and usually you will be able to count that out. But the length of the latus rectum is shorter, and we just calculated down below, actually equals 1. Okay? So clearing that up, I don't think I've ever taught latus rectum before. I don't even know if I've ever heard of it. Maybe I did in high school or in college, but I don't remember it. Brock, will you take your head off, please? All right. Number 2. So we're going to go through these exact same steps. It's just this one's not yet in the right form. So remember that, and this is from yesterday, the ellipse equations have to equal 1, okay? And that's what we don't have in this second example. It equals 100. So if that's the case, it's still an x squared plus a y squared. So that's an indication that it's a circle or an ellipse when you see an x squared term plus a y squared term. But equaling 100, we would want to divide it by 100 on each of the 3 pieces, and that's just going to change it into a much nicer equation. So it's x squared over 4 plus y squared over what? 25. Does everyone see I'm just reducing 25 over 100 to 1/4? 4 over 100 to 1/25 equals 1. So technically, what's my A? The bigger one, right? This is the bigger one is where I get my A. This is technically A squared, so that means A equals 5. It's not about the fraction, it's about just the denominator alone. So technically, if you were following this format, you would actually put your y squared first, right? I don't really care about that. It's just the bigger one, okay? So the bigger one's always A. So if you want to write that again, Brock, stop talking because you're distracting me. A is always bigger than B. So does it really matter if I put y squared over 25 first plus x squared over 4? I don't think so. Addition in any order. The fact of the matter is the bigger one is A. The smaller one is going to give you B, so B is 2. And since the bigger one is under y, this thing is going to be a circle stretched vertically, right, along the y-axis, right? When we talk about a vertical ellipse versus a horizontal, these are stretched more horizontally. That's when the x squared's denominator is bigger. it gets pulled in the x direction. But when the y squared's denominator is bigger, it gets pulled in the y direction. Okay? A and y don't always go together. A is just the bigger one. Yes. A is just always the bigger one. So the center here, we don't have any x minus anything squared or y minus anything, so the center is just at 0, 0. So if I sketch, we'll do it over here. That'll be my center. This is pulled 5 units in the y direction. So the top of the oval will be 1, 2, 3, 4, 5. And the bottom 1, 2, 3, 4, 5. And in the x direction, it's pulled 2 units from the center, so 2 to the left and 2 to the right. That's going to get you your general ellipse shape. Good? Okay. So to find our C value, and these are really the two formulas we have to know. A squared equals B squared plus C squared. That one we have to memorize to find the C value because that's going to help us find the focal points. And then the other one is the lattice rectum one, LR equals 2B squared over A. So those two formulas are really the only additional things I think that we need on top of just the general understanding of how this circle got stretched. Okay? So A squared is 25. I'll do this right side by side. B squared is 4. So I'm going to solve for C. So 21 equals C squared, and then C equals plus or minus root 21. The plus or minus does technically have a role. First of all, your focal points, again, to review from yesterday, always go along your major axis, which is the longer one. So we're going to go root 21 units up and root 21 units down to get our new coordinates of our focal points, right? So 0, 0, if you go root 21 units up, that's just going to be 0, comma, root 21. The question is, like, whereabouts is that? Can you do root 21, Tommy, since I know you just... Okay, so 4.58. 1, 2, 3, 4. It's way out there. So that'll be 0, comma, root 21. And then symmetrically on the other side, 0, comma, negative root 21. And then the length of your lattice rectum will be 2 times b squared, which is 2 times 4, over an a value of 5, so 8/5, which is 1.6. So that's this length right here, just so we know. That's your lattice rectum. 1.6 units long. If you want to write it next to it, LR equals 1.6. So name the center. If I'm going through the instructions now, we named the center. The vertices are your 4 corner points. You just label that right on here. This one's 2, 0. This one's 0, 5. This one's negative 2, 0. And this one's 0, negative 5. So we've named our 4 vertices. Our foci we already did. Vertices, foci. Endpoints of the minor axis, we already have those. I guess I counted those in the vertices, but endpoints of the minor axis are labeled. Length of the lattice rectum is labeled. Length of the minor arc, we just have to, or minor axis, we just have to count that. So that's, you want to write minor equals just 4 units. Yes? And then the major is 10. The lattice rectum, it's going to be, so the major axis connects the ellipse lengthwise. The lattice rectum is the segment that is perpendicular to that goes through a focus. So this one or this one. It's just a small little segment that, there's 2 of them, but they're both the same length because it's a symmetrical picture, so you only have to label one of them. It always has to go through the focus. No, I don't measure it. I calculate its length. You would never be able to measure it, no. But something would be wrong if you got a measurement that was longer than your minor axis, because your minor axis, almost like a diameter, should be the longest segment going crosswise that way. Okay? So that's really the sketching that we just finished up. And then we're going to do 2 more of the same type. It's just they're not at all in that format that we like. Okay, so we just have to complete the square on them, just like you completed squares on circles. So, on this first one, and whenever we were completing the square in geometry or algebra 2, you get your x terms together. So I'm going to rewrite this as x squared minus 2x, and then I'm going to leave some space. So that covers that term and that term. Plus 4y squared minus 16y covers those 2 terms. And then I'm subtracting my 13 over to the other side. So far, so good? Okay. On the x's, if you remember, who can tell me what number you would have to add to make that a perfect square trinomial and factorable? Who said it? 1. How'd you get that? Okay. Who knows how you get it? Because 1 is correct. Cut what in half? Cut the middle term, yep, half of b, and then square it. So take -2, cut it in half, you get -1. Square that, and that's plus 1. So because I added 1 to the left, I need to make sure I keep the equation equal, so I also have to add 1 to the right. So far, so good? What that actually just did for that particular section is it made it a perfect square. And perfect squares can be written as something squared. Right? What does that factor into? What times itself gives you that? X minus 1. Very good. X minus 1 times x minus 1 gives you that. Good? Then we're going to kind of do the same thing on the y, although we have one little extra thing to consider on the y completing of the square. You're not allowed to complete the square if there's a what? Coefficient. So on this little section, I need to factor out a 4. So that's actually going to make it 4 with parentheses, y squared minus 4y. And then I'm going to come up with, what should I be adding in here? Nope. 4. Because once that initial 4 is factored out, what's left over is what you take half of to get -2, and then square to get +4. And then here's the tricky part. You had to do this at times with circles. If I added 4 to the left, but it was in a set of parentheses that had a 4 in front of it, what did I really add to the left? 16. Does everybody follow that? So if I added 16 technically, even though I never wrote 16, if I added 16 to the left, I have to add 16 to the right to make up for that. Okay. So when I add, I put my +4, and then again, this is now factorable. I made that a perfect square trinomial that factors into what times itself. Good. And then my right side is 4. Good? Well, we'll do another one. This plus 4, Mike? I took half of that, got -2, and squared it. Because I didn't just add 4 to the left. I added 4 within a set of parentheses that needs to be multiplied by 4. We did do that. Well, the plus 4 part is where the completing the square came in. Different step. Totally different step. And in effect, by adding 4 in a set of parentheses that's being multiplied by 4, I really actually added 16. So I have to keep it even by also adding 16 to the right. So, okay, good. Okay. So from here, we know it's not a circle, and here's why. Because the coefficient on the x and the coefficient on the y are different, which leads us to realize that they're stretched differently. It's not a perfect circle. I know it's circular, sort of, with the oval shape because it's an x squared something plus a y squared something. That is your indication that it's either a circle or an ellipse. The fact that these are not the same and not evenly balanced in how they're stretched leads us to realize, okay, this isn't actually an ellipse. And ellipses need to equal 1. Yes? So divide everything by 4, which is going to make x minus 1 squared over 4. This one's going to be y minus 2 squared. Technically, I don't need to write it over anything, but I'm just going to write it over 1 just to keep it clear. And then this equals 1. So, the main features we should start with. What is the center beam? Nope. The other one was 0, 0 because it was just x squared and just y squared. This one got shifted right 1 and down 2, or and up 2. 1, 2, very good. That's like an HK. Remember HK with parabolas? We use those same letters, HK, for the center. Whatever's paired with the x, that's your x coordinate of the center. And whatever's paired with the y is the y coordinate of your center. Opposite sign, technically. There's that weird, funny sign thing that happens. So there's your center. So go ahead and sketch your x and y axes just to get this on paper. And 1, 2 is going to be our center. And then what is our A value? 2. What is our B value? Very good. So this got stretched in the x direction, how much? 2. So horizontally, I'm going to go 2 to the right for a point and 2 to the left for a point. And only vertically 1. 1 up from the center and 1 down from the center. And there's the bulk of it. Those are the main features, obviously, of an ellipse. Those are the points that we connect to get it. But then we're going to go and find those other couple things. So we need to find our focus. So that equation was what? A squared equals B squared plus C squared. Okay, if A is 2, then A squared is 4. If B is 1, then B squared is 1. And then subtract 1 from both sides, and C squared is 3. So C equals plus or minus root 3. And remember, C is the distance that the focus is away from the center. So your foci are going to be along your major axis. Is our major axis running left, right, or up, down? Left, right. So I'm going to go root 3 units to the left. Now root 3 is like 1.7-ish. So 1.7-ish will put me there. And 1.7-ish units to the right. So I don't want to, like, especially when it's a smaller ellipse, you don't want to try to squeeze labels in. So I'm just going to, what would the coordinates be for that point? The center used to be at 1, 2. But we took off of the 1, right? We took off how much? 1 minus radical 3, but the y coordinate of 2 is the same. And then to get to that focus, we started at the 1 and we added on root 3. If those were whole numbers, you guys would have zero problem with that. It's just a little bit of a hurdle to just wrap your head around how to handle the radical, adding it on to the 1 and subtracting it from the 1. So those are your focal points. Your length of the lattice rectum is 2b squared over a squared. 2b squared over a. So b squared is 1, so 2 times 1 over a is 2. So the length of the lattice rectum is just 1 unit long. So you can draw in one of your lattice rectums and say LR equals 1. What's that? Yeah, you don't have to draw in two. They're the same thing. Equidistant on both sides. They'll make it look like a football. How's that? Is that helpful? Your minor arc is how long, JR? I keep saying arc because that just rolls. Minor axis. 2. That's here to here. And your major axis, what'd you say, Brock? 4. Good. So what'd I forget? I have the center. Oh, I didn't do the vertices. So those are just your 4 corner points. So negative 1, 2, 1, 1, 3, 2, and 1, 1, 2, 3. There's my vertices. Got my foci. Length of the major, minor, lattice rectum, sketch. Clearly I don't exactly do it in that order. I like to get my sketch there first, my general sketch, and then put all these other things into perspective visually. Good? Okay. So let's review this changing by completing the square together one more time, and then I'll let you try to come up with all those features on your own. So rearrange. How should I rearrange this, Maggie? No, I want to rearrange my x's next to x's. So, Brock, go ahead. 24x, yep. Leave a blank, good. Good. And then move the constant 36 over as a negative 36. Good. Does that make sense, Maggie? Okay. Both of these have their own different coefficients. So, Alyssa, what am I going to do with this? Okay, so I'll have a 4 and I'm left with, good. Still leaving it blank. On the next one, Maya, what do I do? Good. And I'm left with, good. So on both of these, I'm going to have to process what am I adding inside the parentheses to put in there, and then what am I technically going to have to add to the other side to counter that? So Allie, what would you plus inside the parentheses here? Very good. And so to counter that, what would you be adding to the other side? No. Nope. I added 9 in a set of parentheses that got multiplied by 4. So I technically added 36, even though I wrote plus 9. So I have to add 36 to the right to counter that and keep everything equal. She took half of -6 to get to -3 and squared that number. So, Val, what am I going to add inside this set of parentheses? Plus 4, and what am I going to add on the other side to counter that? Perfect. Good. So, now I'm going to factor those trinomials. I completed them and made them perfect squares so that I could write them as something squared. So that it was like morphing into that whole ellipse format. So what does this one, Laura, factor into? X minus 3. And Sarah, what does this one factor into? Very good. And my right-hand side's just 36. So, I know this is an ellipse and not a circle because the 4 and the 9 are different coefficients. Yes? Well, I added 36 once because of 9 times the 4, and then I had to add 36 again because of this 4 times the 9. So yeah, those two cancel, and it just became a positive 36. Paula? So once I realize, okay, this is definitely an ellipse, I need to get it to equal 1, so I'm going to divide everything by 36. And they write these nicely enough where these will like always reduce to a nice fraction. Like, it should never be 5 over 36, so then your numbers would be way too ugly. So this becomes x minus 3 squared over 9, and this is y plus 2 squared over 4 equals 1. Okay, so for the next 4 or 5 minutes, take your time with that. Try to sketch it, come up with those key features in the same order that we've been doing them. Maybe within like the next minute, just have your main ellipse with the center sketched so that we can touch base on your accuracy there before you move on. Maybe I'll just come around and check it. Right, but this one was stretched. Yeah, this one was stretched further in the x direction. So that's a bigger number. By 2 in the x direction, and by 1 in the y direction. So we said pencil. center is 3, -2. Your A is 3, and your B is 2. Good? What step? These two? Okay, so wherever your center is, the bigger number tells you how much it's pulled in that direction. So in the x direction, and this is my x-axis, so x direction would be kind of like left-right. It's pulled from the center by 3, because that's the A value. So I started with my center, and I went 3 units to the right, 3 units to the left, and those are like the vertices on the long end. And then on my y-axis, so it gets pulled up, down by 2. Up by 2, down by 2. Follow? The bigger one's not always horizontal. It depends on what it's under. If the bigger number was under the y, it would be pulling it more in the y direction. So yesterday we did this one. The bigger number was under the y. So it got pulled 5 units north-south and only 2 units left-right. Good? So once you're here, the foci are, again, coming up with the coordinates can be tricky, but they're definitely going to be here and here, right? They're along the major axis. Are we good with that? So if this center is 3, -2, if I'm moving over here, which of these coordinates is changing? The x or the y? The x-axis. So if your ellipse is oblong, like left-right, then when you go to your focus point, you're going to add and subtract off of your x-coordinate to move left to get to a focus and right to get to a focus. Versus yesterday when we saw a vertically oblong ellipse, here was our center, we were moving up to get to our focus, which changes your y-coordinate by adding your c value. And we were moving down, which changes, again, your y-coordinate by your c value. So in this particular case, did you find your c value? A squared equals b squared plus c squared. Radical 5. Okay, so b squared is 4. Yep. So c squared equals 5, and c equals plus or minus root 5. So I'm moving left and right from this. So my focal points, now I'm going to come up with what radical 5 is so I can at least draw this to scale, 2.23. So I can go 2.23 to the left and 2.23 to the right. I'm going to label that. It's no longer 3, -2. It was a 3, but I subtracted root 5 off of that. So my x-coordinate is 3 minus root 5 with the -2. And then over here, I added root 5 onto the x-coordinate. 3 plus root 5 with a -2. Good? I think our 4 vertices are fine as long as you have this placed right. I'm not worried about those. I'm not worried about the length of your minor axis or your major axis because those are countable. The only thing left is the length of your lattice rectum, which is 2b squared over a, which is 2 times 4 over 3. So 8/3, which is 1.6 repeating. Good. So this length here, LR, is 1.6 repeating. No. If you left it as a length of 8/3, that's totally fine. I just think getting it in terms of a decimal makes sense because then you can compare it to your minor axis and make sure there's not a mistake, right? Because your minor axis is 4 units long. That should be under that. Yeah. 2.6 repeating, correct. Good job, Mike. Paying attention. So maybe you don't want to do it because then you'll make more of a mistake like I just did. Should have kept it 8/3. Okay, so I'm going to give you 2 worksheets. They each have, the first one has 3 problems, and the second one has 4. Just relax. You're going to do the odds. So you're going to do 1 and 3 and 1 and 3. The first 2 are just going to be, you don't have to complete the square on. The second 2 you have to complete the square on. So there's 4 of these. Okey doke. I'm going to give theirs to you as well. You too. This is everybody. You and back. So one says ellipsis number 1, one says ellipsis number 2. Get it, you do? Maybe you have more clue if you didn't have your phone setting. Couple of hundreds and 98s on that test from the other day. Sarah, you have to take it. 9, we discussed. Here. Okay, come here.
Yeah, I do.